In this question, it says sodium hydrogen ascorbate is often used as an antioxidant in packaged non-fat foods. The pH of a 0.15 mole per liter laboratory solution of sodium hydrogen ascorbate is measured to be 8.65. From this evidence, calculate the Kb value for the hydrogen ascorbate ion. There are a couple of things that we've got in this question. So first of all, the concentration of the acid is 0.15 mole per liter. And that is going to be my HC6H6O6 negative. So that's the hydrogen ascorbate ion. And when it's acting as a base, it's going to react with water, and it's going to make a hydroxide ion, and H2C6H6O6. So while this is happening, this is the expression that would explain the Kb. And so I want to calculate for this using these values. I know the concentration of the hydrogen ascorbate. And so the hydrogen ascorbate is actually the base entity. It could act as an acid or as a base potentially. And so it's called an amphiprotic species. But here we want to talk about it when it's a base. I can calculate the hydronium concentration directly using the pH. And so if I take the pH, I calculate the hydronium concentration to be 2.2 times 10 to the negative 9 mole per liter. So I could calculate the concentration of hydroxides, because the concentration of hydroxide times hydronium equals Kw. So because of that, I can calculate the hydroxides by taking the Kw divided by the concentration of hydroniums that I learned from the acid, and it gives me a concentration of hydroxides of 4.5 times 10 to the negative 6 mole per liter. And so that's the concentration of this and this. So if I build an ICE table, my initial concentration was 0.15 of this HC6H6O6 negative. My hydroxides are going to be 0 to start off with, and then my H2C6H6O6 will be 0. My change is going to be 4.5 times 10 to the negative 6. This will be 4.5 times 10 to the negative 6. So we were making plus 4.5 times 10 to the negative 6 plus 4.5 times 10 to the negative 6. This will be minus 4.5 times 10 to the negative 6, which when I round it off leaves me with 0.15. So in fact, my assumption would have worked if I'd have used it this time, but I can't check it if I don't know the Kb. And since they're wanting me to calculate the Kb, I couldn't do that. So my Kb is going to be 4.5 times 10 to the negative 6 squared over 0.15. And I come out with 1.4 times 10 to the negative 10 is the Kb value. So experimentally, that's what I would find out for this, and I need to actually use the experimental evidence to find it. Now the last question asks a bit of a weird question. So it says, predict and write the prominent Bronsted-Lowry